Hello guys, this is Harshvardhan. Welcome back to my YouTube channel Harsha CVS. Today we are going to discuss the problem regarding to the Gram-Schmidt orthogonalization. In the previous lecture, we have studied the concept relating to the Gram-Schmidt orthogonalization. Now we are going to solve a numerical on GSO. Okay. Now here we can clearly see that we have got the three signals. The first signal S1 of t, and the second signal S2 of 3, and third signal S3 of t. So we have three signals with amplitude 2, the time 1 with amplitude minus 4, and the time value 2 with amplitude 3 and time value 3. We have three signals. Now we need to start our approaching. Now in order to start the problems related to GSO, we know that our main step one is to find first orthonormal basis function, which is called phi1 of t. It is the s1 of t by square root of energy. What does the energy stands for? Energy, it is stands for energy of the S1 of t. We can clearly see the S1 of t is here. So we will draw the S1 of t in the next page. S1 of t is clearly states that the amplitude is 2 and the time is 1. We mention the axis t and here S1. So in order to get energy of this, what we will do in the if we need energy equal to 0 to Ts, what is this amplitude? S1 square into Dt. This is the formula we will generally use. We know that the time varies from 0 to axis 1 and S1. What is the amplitude? 2. Nice. So 2 square into dt. We will end up with integral 0 to 1. What is 2 square? 4 into dt. So we will finally get 4 into some value t varies from 0 to 1. We will get 4. We will get 4 as our energy. As we know that if 4 is our energy, what is root E? Root E stands for root 4. It means 2. So we can finally conclude that our phi 1 of t equal to s1 of t by root e. We know that. Okay. From that we can define s1 of t by 2. We know that the s1 of t is here, right? This is s1 of t. We can clearly see this is s1 of t. If we divide this amplitude 2 by our value 2, we will get 1. So our phi 1 of t look like this. So our phi 1 of t finally become a signal varying from 0 to 1 on the time axis with amplitude 1. This is phi 1 of t. We have wonderfully calculated the value of phi 1 of t, right? Now we are going to calculate the second basis function called phi 2 of t. In the step 2, we will do? We will calculate phi 2 of t. This is our process. I have already mentioned in order to calculate phi 2 of t, we require S2 tilde of t by root energy. Here energy indicates energy of S2 tilde of t. Now we will mention S2 tilde of t as S2 of t minus C21 phi 1 of t. Okay. Now we will see what is C21. As I have already mentioned with you, it varies from 0 to Ts. This first T stands for signal and second T stands for basis function. So it indicates S2 of t into phi 1 of t into dt. Okay, this is what it indicates. Now we will consider next page. In the next page, we will see that our S2 of t. What is the graph of our S2 of t? If we see our graph of S2 of t, it varies from 0 to 2. It varies from 0 to 2 on the time axis with the amplitude minus 4. What is phi 1 of t? This is what we get as a phi 1 of t, amplitude 1 with 1 on the time axis. Okay, this is what we get. If we multiply S2 with phi 1 of t, we will get the graph as S2 of t. We are multiplying with phi 1 of t. We are able to get the graph with amplitude 4 minus 4 with the time value 1. Right? If we are going to get integration with 0 to 1, S2 of t, phi 1 of t dt, it is called as C21. Why I have considered here as 1 as S2 of t phi 1 minus 4. Okay, we are going to get the value of S2 tilde. S2 tilde will say S2 of t minus C21 phi 1 of t. We got the value of C21 as minus 4. Here we can clearly see. And phi 1 of t is this. Now we will get C21 into phi 1 of t. So we are getting the value as minus 4 to 1. This is time axis. This is what we are going to get. Now, finally, we need to calculate S2 tilde equal to, what is S2 of t? S2 of t stands for minus 4 with the time difference 2 minus, we are going to subtract minus 4 time axis. So we can clearly see that this is S2 of t and this is C21 phi 1 of t. If we subtract minus 4 time difference, so finally we get the value as S2 tilde equal to minus 4 from 1 to 2. And one thing, if I subtract this, this is what we are getting. So this is S2 tilde. Now we finally need phi 2 of t. In order to get phi 2 of t, we will get S2 tilde of t by root e. Now, what is S2 of S2 tilde of t we get? This is what we get. For this, if we calculate the energy equals to from 1 to 2 minus 4 whole square dt. By this time, I hope you will able to calculate the how we are calculating energy. So we get energy as a 16, but root of energy equal to 4. So we will get phi 2 of t as this is value of minus 1, this is t, and this is hopefully we got the phi 2 of t. Finally we got phi 2 of t. Now our third aim is to step 3. What is our step 3? Final. Calculate phi 3 of t. This is what we need to get. In order to calculate the value of phi 3 of t, we will get S3 tilde of t by root t. Here the energy stands for S3 tilde of t. Now we define S3 tilde of t equal to our signal S3 of t minus C31 phi1 of t minus C32 phi2 of t. Now we will calculate the values of the C3151 of t and C3252 of t first, and we will substitute in the S3 tilde, and finally we will get S3 tilde of t. Now we are going for our next page. Now we are going to calculate first of all C31 value. So this is integral 0 to ts S3 of t into phi1 of t into dt. This is what we get. Now, what is S3t of t? This is S3. It varies from 0 to 3 on the time axis. On the amplitude, it's a 3. Now it is S3 of t, and we got what we get as a phi1 of t. This is what we get as a phi1 of t. Here we can see amplitude 1 to 1, it is as a phi1 of t. So we can write this 1 to 1 phi1 of t. If we multiply these two things, we will get a signal ranging from 0 to 1 on the time axis. On the amplitude axis, it is a 3, and this is S3 of t into phi 1 of t. If we get the integration, we get a C31 as integral 0 to 1 3 into dt. The value of C31 is 3. So finally we can conclude the value of C31 equals to 3. Now we are going to calculate C32. What is C32? C32 is integral 0 to Ts S3 of t phi 2 of t into dt. Now we know that S3 of t, S3 of t is a signal ranging from 0 to 3 on the time axis with amplitude 3. This is S3 of t. And phi 2 of t is a signal that is ranging from minus 1 from the value 1 to 2 on the time axis with phi 2 of t. If you multiply these both signals, we will get a signal like this is minus 3, 1 to 2 into t. And what does it is called? It is S3 of t into phi 2 of t. So finally we get C32 equal to integral 1 to 2 minus 3 into dt equal to minus 3. So finally we got the value C32 equals to minus 3. Okay, this is what we got. Now we need to calculate C3151 of t, C3252 of t. Now first we will look at C31 and C3252 of t. Now we are going to calculate C3151 of t. So we are multiplying the value of 3 with 51 of t. 0 to 1, 1 t. This is 51 of t. If we multiply this, we will get the graph as the signal ranging from 0 to 1 with amplitude 3. This is what we get. Now we are going to calculate C3252 of t. What is C32? It is a minus 3 into 53 of t. 52 of t is defined as this ranging from 1 to 2 on the time axis. This is 5 to the main thing. The representations are very important. If we miss any representation, we may get value doubt and we might get wrong answers. Okay, this value is minus 1. If you multiply the minus 1 minus 3, it will get the value as positive 3. It was ranging from 1 to 2 on the time axis with amplitude as a 3. This is C3252 of t. Now we are going to subtract from S3. In order to get S3 tilde, we need to use this equation S3 of t minus C3151 of t minus C3252 of t. Now we got these values, every value in this equation we have. Now we will subtract. First of all, what is S3 of t? S3 of t is defined from 0 to 3 with amplitude 3. This is S3 of t, right? Now we are going to subtract the first one. This is one we are going to, from 0 to 1 we are subtracting. So, minus 0 to 1. Now we are going to subtract the value of 3. This is C3151 of t with the time value t minus we are going to subtract from value 1 to 2 the time axis the value of a 3, it is as C3252 of t. If we subtract, we get the value as 2 to 3 on the time axis with S3 tilde as value, amplitude as 3. Now we need to get the energy of the signal. We know that the energy of a signal is varies from 2 to 3, 3 square dt. The energy we get is 9. If we get the root of energy, it is a root 9. We get the value as 3. So, so finally, S3 tilde we got by root 3 root e which represent the pi 3 of t stands for the value ranging from 2 to 3 on the time axis with amplitude 1. So this is finally we get as a pi 3 of t. So finally now we conclude the value of a phi 1 of t, phi 2 of 3 and phi 3 of t as inflow. Now finally we got the value of, here we will represent all basis functions. This is what we get from 0 to 1, 1, 0 to 1. This is time axis. This is phi 1 of t, and we got phi 2 t as, this is phi 2 of t. We get as, sorry, it should be down. We get phi 2 t as from 1 to 2 on time axis, and this is phi 2 of t with amplitude minus 1. And finally we got the phi 3 t from ranging from 2 to 3 on the time axis. This is phi 3 of t, the value is 1. This is how we will generally compute the orthonormal basis function from the given signal. Hope this example clarified you the many hidden concepts in the GSO, and if you really like my content, please subscribe to my channel. If it might be helpful to your friends, please share with your friends. Thank you so much. Keep watching.